This satellite is called Unhai 102. It flew innocently in space until it collided with some space debris. Now you might think that this is the beginning of our space nightmare. One collision creates debris, which creates even more collisions, and eventually there's so many collisions that space is too dangerous to use. But when I actually looked into our space junk problem, I learned that something was slowly removing this debris from space. And the more I learned about it, the more I realized that even though our space junk problem is very real, this humanity is doomed version of this story is mostly fear-mongering. And even more importantly, this space debris researcher showed me a creative solution that could not only solve a big part of our space junk problem, but turn it into something humanity has always dreamed of. And very few people seem to know about it. So here's our problem. More stuff in space means a higher chance for a collision. Those collisions will create even more debris, which will cause even more collisions, creating a cascade of collisions and making space unusable. This scenario is called the becasue syndrome, and according to popular belief, it's already here. This debris will trap us on the Earth forever. No satellites, no moon, no Mars. And it's not going to stop. The number of objects in space is exploding. In the last 20 years, the number of tracked objects in space has roughly grown by a factor of 5. And this debris is already causing us problems. About twice a year, the International Space Station is on collision course with space debris, and they must make a collision avoidance maneuver.
And when they fly these maneuvers, the astronauts have to go into their escape capsules with which they could fly home, just in case a real tragedy would happen, right? And the space station would hit. If it's really, really risky, they would have to go back home.
Wow.
So space debris is a real problem. But to understand why the Doomsday version is fear-mongering, we first need to understand what space debris actually is. All debris starts as large objects, either satellites or rocket bodies that brought satellites into orbit and remained in space. These large objects are ticking bombs because if they break apart, they can create thousands of new pieces of debris. This smaller debris makes up the vast majority of objects in space. And they are dangerous because even tiny pieces can damage or destroy satellites because they move at extremely high speeds. About half of the debris we can track comes from 2 catastrophic events, which are also the perfect example of how large debris breaks apart. You can probably guess that the first catastrophic event is a collision. The satellites Iridium-33 and Cosmos 2251 collided in 2009. Now, when you think of a collision between 2 satellites, you might imagine something like a car crash. But at those speeds, it's more like an explosion. If only 1% of the kinetic energy was converted, it released the same energy as a Mark 83 bomb. NASA describes it as the most severe accidental fragmentation on record. Accidental fragmentation, because the second catastrophic event was not an accident. It was an anti-satellite test conducted by China. We still never had an active bombing in which one country bombed the satellite of a different country, but many countries have conducted an anti-satellite test to test their own weapon systems. According to NASA, China's test created the most severe artificial debris cloud in Earth's orbit since the beginning of space exploration. The Iridium-Cosmos collision and China's test created a massive amount of debris in space. Okay, but wait a sec. Many countries have conducted an anti-satellite test. Why did I mention only China?
Because China, 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 China.
No. It's because in low orbits, the atmospheric drag force slows down the debris and brings it back to the Earth. Debris in low orbits will fall back to the Earth by itself. The recent tests of India, the US and Russia were in much lower altitudes. The vast majority of the debris from those tests has already re-entered the atmosphere by itself. All the debris from the Unhai 102 collision has returned to the Earth as well. Which brings me to a very important point. Not all orbital heights are equally likely to experience the becasue syndrome. For example, many people are afraid that a large number of Starlink satellites will lead to collisions and later to the becasue syndrome. But Starlink satellites orbit at 550 kilometers and are planned to go even lower. At those heights, all the debris is expected to return to the Earth in about 5 years. Even if we will have tons of debris in those orbits, it will be temporary. Painful, but temporary. But to be fair, when satellites fall back to the Earth, they burn up in the atmosphere and release hot metal gases. And we still don't really know what the consequences of this are. Maybe it can cause some problems we're still unaware of. Every solution comes with its own problems.
There are no solutions. There are trade-offs.
So the Kessler syndrome just can't happen in low orbits. But in high orbits, it's much different. The debris is expected to stay there from decades to millions of years. You kind of have two directions here. Low altitudes have high atmospheric drag force, so satellites sink down, and high altitudes are less crowded, so collisions are really rare. The majority of debris is located between 600 kilometers and 1000 kilometers height. This is where we need to focus on removing space debris. When people say that we've reached the Kessler syndrome, they mean to say that the rate of debris generation is higher than the rate of the automatic cleanup. But we can increase the rate of space cleanup by removing space debris. This is why I think that the public conversation about our space junk problem is rather pessimistic and not really connected to reality. If the threat actually becomes real, governments will respond quickly, because space is super important to us and the stakes are huge. It already happened in the past, in the Montreal Protocol. When the problem became real, governments cooperated and solved it together. Okay, but enough with the pep talk. Let's talk business. Here are several methods with increasing coolness level on how to solve our space junk problem. And the last method made me realize that we think about space junk completely wrong. The first step in cleaning up space is to deorbit satellites at the end of their operational lifetime. In low orbits, we can design new satellites with a very large deployable sail. They multiply the surface area of the satellite, which also multiplies the atmospheric drag force. Because even in high orbit, you still have a tiny atmosphere that can be used to stop the satellite. But here's the problem. How can we deorbit a satellite if it suddenly dies before it can deploy the drag sail? The first option is super cool. Lasers.
Oh, yeah.
First, think how mind-blowing it is that scientists can shoot laser at a 1 centimeter debris in space moving at 7 kilometers per second, and I can kill this fucking fly. So lasers are awesome. The idea is to melt a small point on the debris. It will create a stream of gas out of the material, which will act like a jet engine and decelerate the space debris. Think about a balloon filled with air. It's essentially the same force. Isn't this method super cool? As of today, we still haven't used lasers to remove space debris, but it will probably be our main method to remove small objects in low orbits. In low orbits. High orbits are so far away that they are not even discussed as a use case. We will need way more energy than the laser system can supply. At the moment, we still have no practical method to remove small objects in high orbits. But we have an approach to remove the large objects. Go and get them. Launch a spacecraft that will go to the object you want to remove, grab it through some kind of mechanism, and bring it back to the Earth. The mechanism can be a robotic arm, it can be magnetic docking, it can be a harpoon and a net. The mechanism has only one job: to grab the debris. Simple idea, very hard execution. The capturing spacecraft must match the orbital height, speed, and sometimes orientation of the debris. And remember, the debris is moving in several kilometers per second. Such a mission has not yet been done to actually remove space debris, but it was demonstrated as a proof of concept. And this startup, ClearSpace, which is funded by the European Space Agency, is planning to launch a space debris removal mission by 2029. Their story is actually quite amusing because they wanted to launch in 2025, but their target debris had collided with another debris and fragmented, so they couldn't capture it anymore and they had to delay the mission. In such missions, you must work fast because the clock is ticking. Okay, but wait a sec. Is bringing the space debris back to the Earth actually the right approach? Think about it. We invested a lot of energy in bringing the space debris to space. Let's use it somehow. Don't we want to build a moon base? Space debris is full of valuable metals. Why bring those metals back to the Earth when we can send them to the moon and build a moon base with them? Which is exactly the goal of the company Orbit Recycling. They want to send rocket bodies to the moon, which contain a large portion of the space debris mass. Those rocket bodies are
flying around Earth in very attractive orbits. Attractive orbits in a way that they could be this tiny amount of extra energy pushed further to the moon.
They calculated it and saw that this approach of using space debris as raw materials could halve the cost of bringing materials to the moon, which means that they
Could save Europe 10 billion euros in transportation costs.
Wow! So how much energy can they actually save? In spaceflight, when we talk about moving objects between orbits, we talk about the changes in velocities they must get. Each orbit has its own velocity, and in order to change orbits, we need to add or remove velocity to the spacecraft, which we do by burning fuel. Think about it like a ball climbing a hill. You would have to give it sufficient speed so it can climb successfully. Now, in order to get them to the moon, those large rocket bodies would need an extra speed of
around 2.4 kilometers per second, which sounds a lot, but actually if you want to go from Earth to the moon, you end up more or less at 13 kilometers per second.
So it's a substantial reduction in energy cost. Here's the technology they are developing. First, you need to capture the rocket bodies and bring them to a lunar orbit. This part and its challenges are exactly the same as the other space debris removal projects we talked about earlier. Second, we need to land the space debris on the lunar surface. To do this, they propose to
use a very smart landing process which brings down the space debris objects to the surface and automatically disassembles these objects on the surface and store them in a distributed warehouse. And this very scientific expressed explanation just describes that we simply crash these objects on the surface.
They plan to crush space debris on the moon, which must be so fun at mission control. And it's a smart approach, because landing is a trade-off. You want to land with high speed to save fuel on deceleration, but if you land too fast, the space debris could evaporate, and then you lose precious metals. So they actually run hundreds of simulations to determine the optimal crushing speed. Their approach is to process the metal directly on the moon. First, a rover would create a mold on the lunar surface, so we will have a shape to cast the aluminum into. Then we would melt this aluminum with concentrated sunlight. And once it's molten, we can cast it, turning old space junk into actual structures. And that could be the first step toward an actual moon base. I find their approach so smart and creative because why bring the debris back to the Earth when we can send it to the moon and build a moon base with it? Let's solve both problems at the same time. One giant leap, but this time not in technology, but in mindset. So if you want more engineering stories that change the world, subscribe. Love you!